Welcome. In this section, we will discuss about machine learning based face recognition framework. There are three main modules in the face recognition. Module 1, data pre-processing. Module 2, train features with machine learning model. Module 3, save machine learning model. Let us put this in a graphical format for a clear view. For the collected data or the images, we need to do data pre-processing and embed the features from the faces, that is, faces. Simultaneously, we will also do the labeling part. Let us look into the data pre-processing in more detail. There are three parts again. There are again three steps in data pre-processing. There are collect data, segregate data, and embedding and labeling. Let us look into the step by step what is this process is about. Step 1 in data pre-processing is collect the data. It is highly recommendable to collect the data by your own, like friends, family, etc. Make sure what are the data or images you have collected has at least 100 images of each person. However, for general purpose, I collected the data of 15 celebrities like Barack Obama, Donald Trump, Elon Musk, etc. The procedure is same for your own collected images too. Step 2. What are the data that is collected, the images? Put that in the respective folder, just like this. For example, you can look into my data which is collected, where each persons are placed in the respective folder. For example, we can look into the Amir Khan photos. There are 100 photos are there and that is placed in their respective folder of Amir Khan. And similarly for Barack Obama and etc. etc. Step 3. This is the most important step, which is embedding the features. This process is same as feature extraction, which we discussed in the previous lesson. That is, for each image we need to crop the face and identify the face shape using deep neural network and represent the data in 128 dimensions, which are our facial features. This is the process we need to do for the data pre-processing. Then we will move into the module 2. In this module, we will train the machine learning model for the features that we are embedded. Let us investigate that in more detail. With the features or the data that we have extracted from the faces, we need to split the data into two parts, train and test sets. We will train the machine learning model with the train set and evaluate the model with the test set. This process is repeated until unless we got the best hyperparameters of the model. With that, our model will be ready. Now we are in the final module, that is module 3. In this module, we will save the machine learning model. With that saved model, we will make the predictions with the new images. So this is what our face recognition framework we are going to follow in this section. In the next lecture, we will develop the face recognition model using face recognition framework. I will see you in the next lecture more on this. Until then, happy learning. Welcome. In this lesson, we will do the data pre-processing. Hope you have collected the data of your own, which is highly recommendable in this course. But in this course, I am going to consider the data of 15 celebrities like Amir Khan, Sachin Tendulkar, Barack Obama, Cristiano Ronaldo, etc. Now let us start doing the data pre-processing by loading the data into our Jupyter notebook. I have successfully loaded my Jupyter notebook. Make sure you create a folder named models and inside that copy all the necessary libraries that was used for face detection and feature extraction models, which we discussed in the previous section. Now let us create a new Jupyter notebook and let's do the data pre-processing. Go to New, click on Python 3. Let's first rename our notebook as 1 data pre-processing. And in that we will do all the data pre-processing. First import all the necessary libraries that was used in the data pre-processing. Import numpy as np, import cv2. Let me also introduce one more library, pandas as pd, which is used for data analysis and processing. Also import os, also import pickle, which is used to save the data. Step 1 in data preprocessing is detecting the face. As we also saw in the previous lecture on detecting the face using deep neural networks, right? Let's use that process. Face detection model. So let me also load the model here. So let's write load the model. There are two models we are using in the data preprocessing. Let us first load the face detection model. The first model is face detection model equal to provide the path, which is in the models folder. Now select ResNet 300x300 SSD cafe model. Now also provide the prototext, which is equal to dot models folder. Now select deploy prototext.txt, which we did in the previous lessons. Let us also provide the second model, which is face descriptor equal to models folder. Now select open face version 1 model. Now we just provide the path in the variables. Let us now load the models using deep neural network module in CV2. Detector model equal to, let me use the DNN module in CV2. Now select read from cafe. Since we are using the cafe model, that's the reason we are using this. Then we need to provide prototext and cafe model. Since we already have in the variables, let me provide the variables, which is face detection proto and face detection model. Next, also load the descriptor model. Descriptor model equal to cv2.dnn. This is the torch model. So let me select read from torch. Now we need to provide the model. Let's pass the variable face underscore descriptor. Execute it. That's it. Now with this, we have loaded our model successfully. I will see you in the next lecture more on data preprocessing. Until then, happy learning. Welcome. The next step in the data preprocessing is to apply the images to the model and get the face descriptor from all the faces. Now let us access the folder using the following commands. For Windows, type dir to get the list of directories. To run the Linux or dot commands, use the exclamatory mark dir, and the name of the directory is images. Here now the images are there in each folder for the respective person. Alright, let us create a helper function to extract the descriptor from all the faces that was there in all directories. Time being, I will consider one sample image of Sachin Tendulkar. For that, I will extract the features. Later on, I'll apply all images by using the same technique. Let's go. Starting by reading the image. cv2.mread, take the image of Sachin Tendulkar in the images folder and navigate to Sachin Tendulkar. And take the image 2200.jpg. Display the image using the following commands. cv2.mshow, and the name of the window is Sachin, array is img. Let's set wait key to 0 and provide destroy all windows. Now execute the command to display the image of Sachin Tendulkar. Here we go. This is what the image we are going to consider for time being and extract the features of Sachin Tendulkar. Later on, we'll apply the same technique to all the images. Step 1 in facial feature extraction is face detection. We already did this process in the previous section. Now start the process by copy the image to img. Then compute the height, width of the image. H, W is equal to image.shape and select first two values, which is colon2. Next, compute image blob. img blob equal to cv2 dot, from the DNN module, select blob from image. Provide the image which is equal to image. Scale factor set to 1. Size set to 300, 300. Also provide the RGB mean subtraction equal to 104, 177, 123. Set swap RB to false. And also set crop to false. Next, we will set the image to our model. The model that we are going to be working on here is detector model. So let's take the detector model equal to set input to image blob. Next, detections equal to model detector detection model dot forward to get the detection. So this is actually we are executing the deep learning model. Now consider the images only when the length of detections greater than 0. Since in the previous section we know that there will be 200 detections and we also got the confidence for all the 200 faces. My point here is that we had the data with only one face in each image. So out of 200 detections, we need to take only one detection. That can be selected using the confidence score. That is, select only one face with highest confidence score. Let's write the code. I is equal to np dot take the maximum confidence score. So argmax, let's take the maximum confidence score from the detections, and that's going to be equal to 0, 0, and I just want all the detections in that. Let me take the confidence scores. Basically I'm going to be taking the face with maximum confidence score. So this is consider the face with maximum confidence score. So that's what I'm going to do in this case. Now let's take the confidence score equal to detections. Let's take the detections, and in that detection take the 0, 0, ith position, 2. So with this I can get the face with the maximum confidence score. Now what I can do here is that let's take the confidence score at least take the confidence score at least greater than 50%. Now consider that, then only what we need to do is that I just want to draw the bounding box of this. So let's take the box out of this, and that's going to be equal to detections, and this time it is I know we already did this process, which is I, 3, 7, and I just want to multiply with np dot array. Since we did this process, because this is the normalized values we'll get, and we need to multiply that with the width and the height. Okay, so with that we can get this. Now what you can get, put in a tuple. This is the start x and start y and x and y. That's going to be equal to box, and just take the convert the type into integer. Now we can able to draw the bounding box. Just for reference, take draw bounding box, because are we going to extract that properly or not. So that's the reason I'm going to do. So I'm amg underscore draw equal to take this image dot copy, now cv2 dot rectangle, and take this image, and this is what my image underscore draw. Now my rectangle position start x and start y tag, just provide the diagonal positions. We already know this point 1 and point 2, and this is what my end x and end y. Okay, so let's give some green color, and here it is 0 comma 255 comma 0, and the thickness is equal to 1. Let's do whatever the default is available there. So with that, what we can get here is that we can able to draw the bounding box on top of this. So let's have a look into that by just cv2 dot mshow, and this is what my sample image, and this is my image, and also show cv2 dot mshow and draw image, and that's my image img underscore draw cv2 dot weight key of 0 and cv2 dot destroy all windows. Oh, this is my detections. It's not detect, just changed into the detections. Now execute that. Now this is what my sample image, and this is what my draw image. So it's okay, we can able to detect the face properly. Welcome back. In this lesson, we will see how to extract features from the face using deep neural networks. In the previous lecture, we have seen how to extract the face. Now in this lesson, we will do feature extraction. Now let us start with step 2, which is feature extraction or embedding. Let us crop the detected face, which is ROI equal to image of start y colon end y comma start x colon end x. With this, I can get the region of interest, which is my face ROI. Now get the face descriptors. To get the descriptor from the face, we need to use our torch model, which is the descriptor underscore model. Let us go back to code and calculate the blob from image. Face blob equal to cv2 dot dnn dot blob from image, and the parameter I just want to set is ROI, which is our image, and the scale factor we need to set to 1 by 255, and mention the size to 96,96, and then set the RGB mean subtraction value to 0,0,0. Also set swap RB to true, crop to true. Now let us pass to a description model. Set the input as face blob. Now vectors equal to descriptor underscore model dot forward. So with that, we can able to get all the vectors from the face. Let's print that with print vectors. Now let me remove all these things which is not required for me and execute it. Oh, we got an error. This is not copy, this is set to crop. Just change that to crop. Now let's execute it. Perfect. We got the vectors successfully from the image. In the next lecture, I will see how to do for all the images. I will see you on that. Until then, happy learning. Welcome back. In this lesson, we will see how to extract features from all the faces that we have. In order to do that, let's create a helper function. Using that, we will apply to all the images and get features. Let's do it. Press tab and create an indentation. Now create a function with the name helper and the arguments inside the function is image path. Inside the function, let me add one more line to read an image. So cv2.mread and specify the file name as image path. So with that, we can read an image and perform all operations like face detection, feature extraction from the detected image. The return value for this function is face vectors or face descriptor. Since I know in my data there is only single face in each image, so I just want to return the image feature if detected, or return none if the face is not detected. So return a vector inside the if condition, and outside the condition return none, specifying that if the face is detected then we return vector, else we will return none if the face is not detected. Let me test this helper function. Helper of, let me specify the same image path and execute it. Here you go, we got the output. Cool, right? So with the simple path, I can able to extract the features from it. In the next lecture, we will see how to apply this to all the images that we have. Until then, happy learning. Welcome back. In this lesson, we will see how to apply the helper function to all the images we had and get the face descriptor for each face. Let's write the code. Step 1. Put all the folder name in a list. Folder equal to os.list directory and the main folder name is images. With that, let's print the folder. Print of folder. Alright, we got all the folders in a list. Let us move on to the step 2. In this step, we need to take all file names inside each folder. Let us understand how we take for each file name in one folder, then we apply to all folders. Let me put comment first. Now, file name equal to os.list directory. Mention the folder path, here it is images slash. Let me consider one folder, that is Amir Khan, and print file names. Cool, right? We got all file names in the list. Let us apply the same technique to all file names in a list. For that, I will use for loop. For folder in folders, now file names equal to os.list directory and mention the path, which is images folder, and let me insert the values dynamically. For that, it is a format and the value I just want to insert is folder. Perfect. We got all images of Amir Khan, Angelina Jolie, Barack Obama, so on, which means that we have successfully extracted all file names in an individual list. In step 3, we will put all file names in one list. For file name in file names, print file name. Excellent. We got all file names in a list. Now let's move to the step 4. In this step, we will extract the face descriptor or face vector for all detected faces. Vector equal to, let me use helper function. An argument for this is just provide file path, which is in the images folder. We dynamically insert the folder name and file name in a format. With that, we can get vectors for each face. And the next step is we need to append all the vectors in a list. Since in helper function we have either a vector or none, we only want the vectors to append and skip all the nones. For this to happen, let us use if condition to append it. If vector not none, then this condition satisfies, then we need to append in some list. First create variable data in dictionary and we will append all the values into it. Data equal to dictionary of data equal to create an empty list and also create another key with a name with label and initialize with empty list. Now append all values into the data. Data provide the key data dot append vector, and let me also append the label which is data of label, and the label for this image is folder name itself. Append folder which is my label for that image. Since in this process you might encounter exception errors, to handle those exceptions we will use exception handlers. Now try what are the code you want to put exception. If there is an error, then put them inside the try and accept pass, which means just skip it. Now execute it. Usually take 10 to 20 minutes, depends upon your data. I will see you in the next lecture more on this. Until then, happy learning. Welcome back. I completed the feature extraction and labeling process. Now let me look into the distribution of labels what we have. From the data, if you look into the keys, we have two keys are there. One is data, another one is label. We are interested in the label at the moment. Let us look into the label. As you can see here, we have all the names of the faces that was stored in the variable data of labels. Now let's calculate the distribution with the pandas series and value counts. pd.series of data of label dot value counts. Here you can see the label distribution is almost uniform. Highest number is around 125 and the lowest is at 95. Cool, right? The next step is save the data into pickle file format, and that was using in the machine learning to train the model. So pickle.dump, provide the object you want to save is data, and the file name you want to save is open data underscore face underscore features dot pickle. And the mode of operation is WB, meaning write in bytes. Now execute it. We have successfully saved our model in the pickle format. Even you can see in the particular folder where you are working on, and the size of the data is 891 KB. I will see you in the next lesson on how to train a machine learning model for face recognition. Until then, happy learning. Welcome back. In the previous lesson, we have seen how to do the data pre-processing, and also we extracted the features, and that features we have saved in the pickle file format. In this lesson, we are going to take those features and train with our machine learning model. So let's go now. Create a notebook with the name to_train_machine learning model. Let me open that. So first and foremost, what we need to do is that let's import the three main libraries, that is NumPy, Pandas, and Pickle. Let's execute this. In training the machine learning model, basically there are four main modules out there. Module 1 is about the data. In module 1, we will load the data from the pickle file and split the data into independent and dependent variables. Then we will split the data into train and test set. In module 2, we will train the machine learning model. And in module 3, we will find out the best hyperparameters using grid search method. And finally in module 4, we will save our machine learning model. Let's get started here with module 1, which is the data. First and foremost thing, we need to load the data from the pickle format. So let's take the pickle dot load. Here I need to provide the file in which the data is stored in the pickle. So let me give the file with open, and the name of the file here is data face_feature.pickle, and also provide the mode equal to read in bytes equal to RB. So that's it. So let me save in a variable data, execute it. Let's print it, and here you go, we have the data, and that data is have a data type of dictionary, which actually we did in the previous lesson. So now what we will do, let's split the data into independent and dependent variable. Let me take the x, which is my independent variable, equal to data, and provide the key data. What we are doing is we are taking all the features and putting that into the variable x. Let me convert that into np.array. This is my independent variable, and similarly y equal to np.array data of, and what we need to provide here is label. That's my dependent variable. Okay, that's it. Let's execute this. So with that, we have able to split the data into independent and dependent variable. Let me look into the shape of x and y. X dot shape and y dot shape. Alright, so what you can see here is that we have 1652 rows, and each and every vector is 1 by 128. And similarly y, we have 1652 values out there. Okay, so this is in the third dimension format, and we really don't require the third dimension format. So what we will do, we will reshape that into 2 dimension. Let me do that. X is equal to x dot reshape, and the shape I just want to reshape is -1, 128. What exactly I'm doing here is that -1 indicates that 1652, and 128 indicates, like, I'm just simply getting 128 columns. That's it. That's what exactly I'm doing. Let's look into the shape again. Okay, so we have successfully modified the shape of our data. Now the next step in the data is split the data into train and test set. In order to split the data into train and test split, let's use sklearn. So split the data into train and test. I'm going to use scikit-learn. Let's import it from sklearn dot model selection import train test split. Execute it. So now let's take the variable xtrain comma xtest, ytrain comma ytest. That's going to be equal to train test split. And here what I want to do is that I simply need to provide the arrays, which is nothing but x comma y. Then I'll take the train size. I want the training data of size of 80%, and remaining 20% should be on my test size. So that's what I'm going to consider, and mention random state to 0. That's it. Execute it. Let's look into the shape of my variables xtrain, ytrain, xtest, and ytest. So let's do that. Xtrain dot shape comma xtest dot shape, ytrain dot shape, ytest dot shape. Execute it. And here you go. What you can see here is that this 1652 rows has been splitted into 2 sets. One is train and second one is test. In train set we have 1321 rows, and in the test set we have 331 rows out there. So that's what we can able to get split the data into training and testing. I'll see you in the next lecture on how to train the machine learning model. Hey everyone, welcome back. In this lesson, I'm going to show you how to train a machine learning model. You can use whatever the machine learning model. It need not be necessary that you need to follow my machine learning model. If at all you want to train with the other machine learning models, you can also go ahead and train that with your machine learning model. However, I'm going to show you the 3 machine learning models to train the face recognition, and that 3 machine learning models, I will combine them using voting classifier. Okay, so let me take that. First, let's import the machine learning models. The machine learning model I'm going to use here is logistic regression, support vector machine, and random forest. So let's import that. From sklearn.linear model, let's import logistic regression. Let me take one more machine learning model, which is support vector machine, which is most widely used machine learning model for training image processing applications. So let's take that. From sklearn.svm, import svc. Now also take the random forest. From sklearn, it's an ensemble method, import random forest classifier. Here I'm going to use a 3 machine learning model and I will combine them using voting classifier. So let me also import the voting classifier. From sklearn.ensemble, import voting classifier. Using voting classifier, I'm going to combine the 3 models and select the output based upon the voting method. It is pretty straightforward stacking model. Since I just want to evaluate my machine learning model, so that's the reason let's also import the classification report from sklearn.metrics. Let's import that. From sklearn.metrics, import classification report and also import accuracy score and F1 score. Now execute it. Let's start the training process with logistic regression. So let me take logistic regression. So let me take a variable model underscore logistic equal to logistic regression. So these are all the parameters that was commonly used in the logistic regression, but one thing you need to keep in mind is that logistic regression is a linear model and there will not be much more hyperparameters to tune them. However, there is one slack variable C is there, and using the slack variable C you can tune the logistic regression. But anyway, let me take what are the default settings are available. Let me take the logistic regression. Now fit my model using xtrain and ytrain. Let me take that model underscore logistic dot fit and just provide xtrain comma ytrain. What you're doing in this process is basically you are training a machine learning model. More precisely, you're training logistic regression. Execute it. So done. So my logistic regression has trained successfully. Let's look into the accuracy score and also the F1 score for both my training as well as my test set. The reason why I'm checking the accuracy and F1 score for both training and testing is to check whether my model is overfit or underfit. Most of the cases, logistic regression is underfit model. Anyway, let's look into that. For that, let's take the y underscore predict underscore train equal to model underscore logistic dot predict, and what we need to pass here is that we need to pass the x train. So with the training data, and we can get the y train results. Similarly, y underscore predict underscore test model underscore logistic dot predict. Let's give x test. So with that, we can able to get the predicted results for training as well as for testing data. So let's calculate the accuracy score and F1 score. Accuracy score for training. So ACC train equal to, since we already imported that accuracy score, let's use that accuracy score, and what I need to provide here is y true and y predict. The y true values is my train for the y predict train, And with that, I can get the accuracy of the machine learning model for the training set. Similarly, let me take the test accuracy, which is what my accuracy score, and let's pass y underscore test comma y underscore predict underscore test. Similarly, also calculate the F1 score. F1 score is basically the combination of precision and recall. It is also one of the most important metric, and that is widely used to validate your machine learning model. So let me calculate the F1 score. F1 score for train equal to F1 score, and what I need to do is that I just need to provide the y true. Y true is my y train for my predicted value of train, and the one thing I need to provide here is average. By default, it is assumed that the data is binary, but my data is not binary, so that's the reason I need to provide some average to macro for multi-classification data. So I'm providing average to macro, which is generally used for multi-classification data. And similarly, let me also calculate the F1 score for test equal to F1 score, and that's going to be equal to y test, and the predicted value is y predict test, and also provide average to macro. That's it. So we have successfully calculated the accuracy and F1 score. What we will do, let's display it. Print accuracy for train, that's going to be equal to ACC underscore train. Similarly, also print accuracy test equal to ACC underscore test. Let me copy and paste it here, and this is accuracy. Instead of accuracy, let me put F1 score and F1 score here. And this is not accuracy train, this is a F1 score train and F1 score test here. What you can get, let's execute that, and you can see here, and what we can see is that we got 73% accuracy for the training data and 68% accuracy for the test data. Obviously, it's a good result. Actually, with the linear model, you can able to achieve the 70% accuracy. It's a good model. What I will do, instead of displaying the so many float values, let me display only the 2 decimal points. For that, I can use percentile 0.2f, which will display only 2 decimal points. So let's copy and paste it here, paste it and paste it. Okay, instead of comma, let me put percentile. Execute it. So with that, you can see we got the 2 decimal points. Since I just want to do the same thing for the support vector machine and random forest, even for my voting classifier, what I will do, let me put everything in one function. So let's select all and put some indentation. Now def, what I need to provide here is, this is what the get report. Okay, the inputs for the get report will be my x train, y train, x test and y test. So this is what basically I need to provide, and I can able to get the accuracy train, accuracy test and F1 score for train and test respectively. And this is not the logistic regression anymore, and I need to replace that with some model. And let's copy and paste this, because that's not logistic regression anymore. Okay, now let's execute this. Oh, we have some syntax error. Let me put semicolon here. Now execute it. Got it. Now we can use this get report so that we can get the accuracy and F1 score for train and as well as test. Let's provide model comma x train comma y train and x test comma y test. Let's provide all the values. Oh, this is not model, this is model underscore logistic. Now you can see that we can able to get the accuracy train, accuracy test, accuracy F1 score train and F1 score test. Okay, so we got some results. Let's also do it for support vector machine and random forest. In the next lesson, we will see how to train the support vector machine and random forest too. Until then, happy learning. Welcome back. Let me also train my faces with support vector machine. Support vector machine is one of the most widely used model, particularly for image processing applications. Let us use the support vector machine and train it. And what we need to consider is SVC. Okay, now model underscore SVC equal to the model name, the object is SVC. And here are the few hyperparameters. One is C, is basically a slack variable, is one of the hyperparameter, is definitely used to tune my support vector machine. And also kernel is RBF. The one of the most widely used is radial biases function. I really don't want to change that because we can able to twist and turns with an infinite number of dimensions with RBF. And one more hyperparameter which I really interested is gamma. Gamma really plays a very important role for getting the best results for support vector machine. For timing, what I will do is that let me use what are the default settings that was there in support vector machine. Later on in the parameter tuning, we might find out the best hyperparameters. Okay, let me set all the default hyperparameters that was already available. But one thing what we will do, let me set the probability equal to true. Now let's train my support vector machine. Model underscore SVC dot fit, and what I want to do here is that I need to pass X train and Y train. Execute it. That's it. So we have successfully trained our support vector machine. Let's get the report of support vector machine. Let's copy this and paste it here. And what I need to provide here is that I just need to provide the, instead of logistic regression, I have to send model underscore SVC. Let me execute it. Awesome, right? You can see the train accuracy of the support vector machine with the default hyperparameters is 0.84, that is 84%, whereas in the logistic regression it is 74%, and the test accuracy is 71%. It is improved compared to the logistic regression, but one thing we can say that the support vector machine is not overfitted. So this is how we can train the support vector machine model. I will see you in the next lecture with one more machine learning model, that is random forest. Welcome back. Let me also train the random forest and get the report of random forest. So let's take the model underscore RF equal to random forest classifier, and obviously there are a lot of hyperparameters that was there, like number of estimators, criteria, max depth, and so on. But however, we are not at all considering all these things at the moment, and maybe in hyperparameter tuning we might consider all those things. Okay, for time being, let me take the random forest classifier and let's train my model underscore RF dot fit. What we need to do is that we need to provide model underscore X train comma Y train. Execute it. Done. We have successfully trained our random forest classifier. Let's get the report of this. Copy and paste it here. What we will do, let's replace this model underscore SVC with model underscore RF. Execute it. And what you can see here is the train accuracy of the random forest is 100%, whereas the test accuracy is 71%. Even though the test accuracy is 71%, it is not a good recommendation to go with the random forest right away. The reason because is we can see my model is highly overfit. So we need to do some kind of a parameter tuning to get out of this. The one thing what you can do is that hyperparameters, probably the number of estimators. If you reduce the number of estimators instead of 100, you can select somewhere between 10. Maybe you can see your accuracy is reduced, but still you can see it is highly overfit in nature. That is, train accuracy is 99%, whereas test accuracy is just 56%. Maybe with the different hyperparameters we need to check what exactly the parameters we need to consider. Maybe with the different hyperparameters, if we tune that, we might get some good accuracy. For time being, so this is what the report, what you can see is that random forest is highly overfit, and the best model out of these three I can found is the support vector machine, followed by logistic regression, and the random forest is the least. Even though most of the people will not agree with my statement, but for this data random forest is not performing really well. So that's the reason, like, if at all I want to give the ranking, support vector machine 1, logistic regression, and the random forest. Maybe with the different hyperparameters of random forest we can still able to get the very good results. In the next lecture, what we will do, we will combine the three models using the voting classifier, and then we will do the parametric tuning. Until then, happy learning. Welcome back. In the previous three lessons, we see how to train your machine learning model with machine learning algorithms. Now what we will do, we will use this voting classifier and combine all the three machine learning algorithms. You can use n number of machine learning models, and we can combine this one of the most popular technique using voting classifier. I'm using the voting classifier and combining the three algorithms: logistic, support vector, and random forest. Let me use this. So model underscore voting equal to voting classifier. Voting classifier is one of the ensemble learning technique, and we can use it to combine the machine learning models. So here we just provide the estimators. Here we need to provide the estimators. So estimators equal to, we need to provide the estimators in a list. So let's take a list. Now let me define the machine learning models in a tuple. The first one is logistic regression, and let me set the logistic regression is logistic regression. Next is support vector machine, so SVM, and what I need to provide here is SVC, and make sure you set the probability equal to true. And one more machine learning model is random forest RF, and which is random forest classifier. So that's it. So this is how I need to provide the more estimators for voting classifier. And the next in a list I need to provide here is voting method. And the voting method is, there are two kinds of voting method is being there. One is soft voting and second one is hard voting. So for time being, let me use a soft voting. That's it. So this is what the parameter settings of voting classifier. Let me execute it. Now let's train this voting classifier model. So take this voting classifier dot fit, and what I want to pass here is x train and y train. That's it. Let me execute this. Done. So we have successfully trained our voting classifier model. So let's get the report of the voting classifier model. Let me copy this and paste it here. Instead of model underscore RF, let me give model underscore voting. Now execute it. So this voting classifier is basically the combination of three models, that is random forest, support vector machine, and the logistic regression. And what we got here is the train accuracy is 94 and test accuracy is 70%. And still what I got here is my voting classifier is basically the overfitting model. The reason of getting the overfitting model is because of this random forest. That's the reason. There is a one more hyperparameter in the voting classifier is weights. Let me provide the weights for each and every model, and the weight I just want to provide based upon the ranking. I need to provide the more weight to the support vector machine, followed by logistic regression and random forest. So let me do one thing. Let me give the more weightage. For example, for logistic regression let me set 2, and for support vector machine let me set 3, and for random forest let me set 1. So what I want to go do here is that more than the value you have given means more weightage you are giving to particular classifier. So you can see the index number 2, which I given the more weightage. That means for support vector machine I have given the more weightage, and for random forest I have given the less weightage. So that's what I'm going to give in this case. Now let me execute this and train the model, get the report. Here I go. Now you can see that instead of getting the train accuracy for 94%, now we got a train accuracy to 88 and test accuracy to 70%. Okay, but still we can still improve this by using the best hyperparameters. I will see you in the next lecture on that. Until then, happy learning. Hey everyone, welcome back. In the previous lessons, we have seen how to train our machine learning model using different machine learning algorithms. And also we saw how to combine all the machine learning algorithms using voting classifier. Now what I'm going to do in this case is that let's do the hyperparameter tuning. That means getting out the best hyperparameters from the each and every models. So here I'm going to use the grid search method for hyperparameter tuning. The first what you need to do, let's import the grid search from model selection using sklearn. From sklearn dot model selection import grid search cross validation. Let's import it. Now model underscore grid equal to grid search cross validation. And here I just want to provide the estimator for which I just want to provide the best hyperparameters. The estimator I want to find out the best hyperparameter is voting classifier. Let's take this model underscore voting, that's my estimator. And then we need to provide the parameter grid. Let me take the parameter grid. Param grid, what I'm going to do here is that I just want to provide all the parameters in a dictionary. Let me create a dictionary and now let's write down all the parameters. Here my interest is mainly into the models like support vector machine and random forest, where there are a lot of hyperparameters are there for which we need to get the best hyperparameters. Whereas in the logistic regression is underfit model, so we have only one variable, that is slack variable c. Using that we can improve the model accuracy. But I don't want to do anything with the logistic regression. Let me use that because I want one linear model because not to get overfit. So that's the reason let me use a logistic regression with the default hyperparameters. Now let me take the hyperparameters for SVC. And basically the hyperparameters for support vector classifiers that I'm going to use is slack variable c. If you increase the slack variable, there is a possibility that you might improve the accuracy of the model. But there is one problem with that. If you increase slack variable, your model might also become overfitting. So that's the reason what I'm going to use is that I'll select some few slack variable, not too big, not too small. So I'll select some slack variable between the values from 1 to 10. So let me set the slack variables, that is since it is a SVM, so let me provide SVM underscore underscore, now the slack variable c. And what I want to do here is that what are the values I just want to test my machine learning model, just provide here. And the values I want to provide here is anyway 1 is the default value. I really don't want to test it, but I just want to test with the variables like 3, 5, 7 and even 10, because even 10 we can able to get the good results. So that's the one hyperparameter. And the next hyperparameter I'm interested in the support vector machine is, let me look, oh, this is logistic regression. Yeah, so here the kernel, obviously I'll go for the kernel radius batches function, and the gamma, it plays a very important role. Let me take the gamma, that is svm underscore underscore gamma. See why I'm writing this SVM. This notation indicates that you are using the support vector machine from this variable. We need to specify this notation to call the particular classifier. That's the reason I'm writing SVM here. Anyway, let's take the gamma. Anyway, let's take SVM underscore gamma. Now provide the list of gammas, that is from 0.1, 0.3, 0.5. so those three are enough. Like, even if you increase that, there is a possibility that your model might get underfit. So that's the reason I don't want to increase much. Let me check one more hyperparameter what we are interested, and this is in the support vector machine. Okay, I think that's it. So these are all the hyperparameters I really interested in SVM. And coming to the random forest, the hyperparameters I'm interested in the random forest are, let me look, which is obviously the number of estimators. I really interested in the number of estimators because if you increase the number of estimators, there is a chance that your model might get overfitted. So that might be the reason, like, the random forest got overfitted. So let me take this. What I'll do here is take the call rf underscore underscore, and now n estimators. Let me call this n estimator from the random forest. Yes, n estimators. Let me send the list like 10, 20, 30. I think even 30 there is a possibility that you might end up with overfitting. So let me give 5 here, 5, 10 and 20. And one more hyperparameter is rf underscore underscore is max depth. Max depth plays really important here. Even though the random forest is basically the full grown tree, but whenever your model is overfitted, then that is might be because of the max depth. So that's the reason you set the max depth to some less values, like maybe you select only the max depth is equal to 5 or 3. You can reduce the overfitting the model. So that's the reason. Let me select the max depth to 3, 5, 7. You can give n number of values you want, but it will take a lot of time for doing the parameter tuning. That's the reason I'm selecting only the few values. So let me check any hyperparameters I'm going to be interested here. The one thing, the hyperparameters you can choose is max features. That is also, it's on your own. You can choose what are the hyperparameter you want. And also the criteria is Gini and entropy. There are two hyperparameters, and based upon the algorithm there is a possibility, but I really don't think that really affect my model. So that's the reason that I'm leaving that part to you. If you really want to check, you can check that. Okay, now coming to this voting classifier itself. In voting classifier there are two kinds of voting are there. One is soft voting and second one is hard voting. What I will do, I will use this also one of the hyperparameters, soft and hard voting. Let me take voting, and the hyperparameters are soft and hard. So that's it. These are the two values I just want to test, like, which is good, either soft voting is good or hard voting is good. So this is all the parameter grid I just want to test with, and just want to extract the best hyperparameters out of this. Alright, so and the next in the grid search parameter is scoring, and how you are going to evaluate your model. I just want to evaluate my model using accuracy. So let me provide the accuracy. That's one thing. Next is cross validation, CV. You can set what are the cross validation you want. If the good number is between some 3 to 10, I'm going to select some cross validation is equal to 3. That's enough. If you want to increase the cross validation, it's up to you. You can increase the cross validation and test your model. So I think we are done. Now what you can do is that let's set the number of jobs is equal to 1. So suppose if you're working on very good computer, then you can set to -1 to run all the models in parallel. But highly recommendable to go to n jobs is equal to 1, because I just want to check step by step and not to lose all the information. That's the one reason I really want to go for n jobs is equal to 1. And one more parameter I just want to specify is verbose. Let me set verbose is equal to 2. What it is going to get is that we can display the output during the process, because it will take a lot of time in order to find out the process where exactly this verbose will be extremely important. Now what we will do, our model underscore grid is ready. Let's fit the model. Model underscore grid dot fit x train comma y train. Okay, the output of this we are expecting is to get the best hyperparameters. Let's execute it. Done. Now you can see that we have total 216 combination of hyperparameters are there, and the model is going to fit 648 models is going to fit. So it'll take quite a while, and please be patient. Do not stop this process, otherwise you need to do it again. So that's the reason, don't stop it. At least it'll take some 5 to 10 minutes. Please be patient while it is running. I'll see you in the next lecture once this process is done. Until then, happy learning. Hey everyone, welcome back. I completed the grid search process. It took almost 10 minutes to complete this process. And you can see that we have 216 candidates and 648 fits. Out of that, we got only one best parameter, which we got the very good score. Let's look into the best hyperparameters. So let's take the model underscore grid dot best estimator and now execute this. And here you go, you can see this is the parameters of the best estimator. For SVM, we have C is equal to 3 and gamma is equal to 0.5. And similarly for random forest, we have max depth is equal to 7 and number of estimator is equal to 30. So with this, we got the best hyperparameters. And the voting what we got here is soft voting. So this is what the best hyperparameters what we got. So let's save this model, which is model underscore best underscore estimator equal to this. Let's look into the score of the best estimator what we got. For that, let's take the model underscore grid dot best score. The accuracy what we got for this hyperparameters is 0.71. Remember, this is the cross validation score. It's not the simple accuracy. The score what we got is a cross validation score. The cross validation score 0.71. It's a really good model. It's a very stable model, means you will get the good results. Out of 10, your model can able to detect 7 correctly. That's really good. That's really not bad. If at all you want to still increase the accuracy of the model, then what you have to do is that just increase the data. As you take more and more data, there is a possibility that you will get more and more accuracy. That's what, the power of machine learning, and that's what the good thing about the machine learning tool. And now what we are going to do here is that let's save our best estimator in pickle format. So let's save the model, which is pickle dot dump, and here the object that I want to dump is model best estimator. Let's take this model best estimator, and the next is file, where I just want to mention the name of the file which I just want to save. Okay, here I just want to save my file in the models folder. So let's provide the path of this. Let's create an open and provide the path which is in the models folder, and the name of the model that I want to save here is machine learning, and this one is face person identity. Okay, .pkl. It's a pickle file I just want to save. Next, I just want to provide the mode of operation, which is write in bytes. That's it. Let's execute it. Now we have successfully saved our model in the models folder with the name machine learning face underscore person identity recognition. So let's go to my home page and have a look into that. This is what the models folder, and you can see that we have saved our model successfully with the name machine learning underscore face person identity dot pickle file. It's very small size. You can see it is just 1.83 MB. Awesome, right? So this is how we can train any machine learning model. I will see you in the next lesson more on this. Until then, happy learning. Welcome back. In this lesson, we will see how to train facial emotion. And first thing, make sure you download the data from the resources, or even you can download the data from the Kaggle competition, but you need to do some bit amount of data pre-processing to make it clean. I already did that process, and those things is being saved completely in the emotion data. And you can open that and you can see there are 7 folders out there, like angry, disgust, fear, happy, neutral, sad, etc. Inside that you can find the bunch of images out there which represents their respective emotion. For example, this is angry. You can see all the angry photos are there here. And similarly, you can also find the happy, fear, etc. So what I did exactly, I prepared the data just like we did for the facial recognition. Now let's open the Jupyter notebook and we will work on data pre-processing and training the machine learning model. Let's open the Jupyter notebook. Okay, now I have to open my Jupyter notebook, and this is what the notebook structure what I'm having with me. And remember that we have the two programs is already created, and one data pre-processing, this is for facial recognition, and two train machine learning model, this is also used for training the facial recognition data. The data pre-processing technique what we are going to use same as we did for facial recognition. So that's the reason what I will do. Let me check this box and click on duplicate, and click on duplicate here. Now we can able to get the duplicate program of data pre-processing, because we don't want to write really, because all the program is already written by us, so we just make use of this. Now check this box and click on rename, and just rename this as 3 data pre-processing and name it as emotion, to specify that we are using for the emotion data. Now let's open this Jupyter notebook. Alright, so we have all the code structure is already there with us. So let's use this code and do some minor changes to make the code happening. The first step is obviously we need to import all the necessary libraries like NumPy, CV2, Pandas, OS and Pickle. And then also we will load our face detection model. Please execute this. And here it's not the images folder, it is the emotion folder. Basically it is the emotion underscore data folder is where my all the data is present. And if you look into the structure, that emotion data, here you can see the directories like angry, disgust, fear, everything is there with us. In order to check our path is correct or not, let's read the data. It's not images anymore now, it is emotion data. Now select anyone emotion, something like angry. Now select any one image out of this, probably 0.jpg. Now execute it. Here you go, this is what the image we have, and this represents the emotion angry. So okay, our path is ready now. Now we created the helper function. Let me also execute this helper function. Now create the data here, which consists of label and this. And here we need to do bit amount of changes. The first thing we need to understand is that all my images are there in the emotion data folder. So what we need to do here is that just change that images with emotion data. Change that into emotion underscore data. And similarly change this into emotion underscore data. And what you can get is the respective folders, and that respective folders what we can apply this to the helper function. And please change that into this also into my emotion underscore data. And what you can get here is the vectors, and if vector is not none, don't append it, otherwise we need to append this into the data and label. That's it. Let me execute this and extract the features from all the emotion data whatever we have. Alright, my program is running. I'll fast forward this process and we will see the next process. Okay, I completed the process. It took me some 15 to 20 minutes to complete this process. Now let's look into my keys, and also let's look into the distribution of the samples what I had. For neutral, I'm having 292 rows are there. For sad, I'm having 260 and so on. You might be wondered that like we have so many images in the folder, but we are unable to extract the feature. The reason is quite simple, because the size of the image is very small, which is 48 by 48 pixel, and extracting the features from that is sometimes it is difficult, and the model unable to extract the landmarks out of this. So that's the reason we can't able to extract the features for most of the images, but at least we got few images where we can able to extract the features. Okay, done. So once we extracted the features, now the next step is save it. So this time let me rename that face features, and it is my emotion. So I have saved my data successfully. I will see you in the next lecture on training the emotion data. Until then, happy learning. Hey everyone, welcome back. We have successfully saved our data in the previous lecture, that is data underscore face feature underscore emotion dot pickle. So now what we're going to do, we will make use of this data and train our machine learning model. Our code is almost ready. That in the previous lesson we already did this code. So let me take this code to train machine learning model. Let me click on the checkbox and click on duplicate and click on duplicate again. We can get the duplicate of this. Now rename this as 4 and exactly same thing, just remove this copy one to emotion. Done. So now we have this program with me. Let me open this program. Alright, we built all the code in the previous lesson. What we will do, just change the data and execute our program. That's it. First, obviously import all the necessary libraries, execute it. Now in the data equal to pickle.load, what I just need to do is that I just need to change this data to data. This is my face features emotions dot pickle. So that's the one thing I just want to save now. Now execute it, and let me also split the data into independent and dependent. Then let's just look into the shape, and here you can see, like, we have 1413 rows are there with the shape of this. Let me reshape that into -1 comma 128. Then we will split the data into train and test and execute this, execute this, execute this, and now we have successfully split the data into training and testing. And here you go, you can see, like, 80% training. So here we have, like, 1130 images for train and 283 images for test. Let me use the same machine learning combinations what we did in the previous lessons. So let me execute this, and first let's train our logistic regression and look into the report of this. Obviously, as I said in the previous lessons, like we are going to get very low accuracy with this. You can see the train accuracy is 31% and test accuracy is 23%. So that's obviously expected because, like, it's very difficult to train such a data. And let me also look into the how my support vector machine is going to be trained. Let's execute this, and you can see, look into the result, and you can see the test accuracy is very low. Even it is a 25%. My logistic regression and support vector machine almost same in the level of test accuracy. And coming to the random forest, let's execute this for number of estimators is equal to 10. And now execute this, and what you can look into the result is that we have accuracy. What I got here is 47%. The one thing you can remember, that 47% of test accuracy is really good actually, but if the model is not overfit, then this is really very good result. I tried with the different deep learning models like convolutional neural networks and applying the different techniques like kernel PCA and convolution neural networks. The maximum accuracy for the test data what I occurred is nearly equal to 60%. Not even 60, it is less than 60. And doing the deep learning model and deploying the deep learning model in the cloud platform is beyond the scope of this project. So with the machine learning, we will take whatever the accuracy we got, we will take that accuracy, and our main intention of using this emotion model to only give the probability of whatever the emotion we got. For that sake only I'm using this model. Let's combine all the models using the voting classifier. Let's execute this and execute this. Now let's get the report of the model. Okay, here you can see one thing, you can see the overfitting is reduced. We have the test score of 40%. What I can do here is that reduce as much of overfitting as possible, and that will be the good thing. So let's see with the parametric tuning, let's see what we can do in this case. I'll use the same param grid and try to get the best parameters whatever I got with high cross validation score. Let's execute this and execute the grid search and execute this. Now let's fit the model for 216 candidates. It will take a time. I'll fast forward this process and continue after this. Okay, I finished all the process of training all my machine learning model, Now let's take the best estimator and also print the best score. And what I got here is I got some 32% is what the cross validation. I think it is better, like 32% compared to my support vector machines and overfitting. The cross validation score is 32 percentage. It's okay. It's not that great model, but it's okay. So what I'll do, I'll use this model and I will save this model now. So what exactly, I just want to change the name machine learning, and this is a person identity. I'll replace that with face emotion dot pickle. So that's it. So this is how we can able to train the model and save the model. Let's execute it. Done. That's it. I'll see you in the next lecture on how to pipeline the model. Until then, happy learning. Hey everyone, welcome back. In this previous lessons, we have seen how to train our emotion recognition model and the face recognition model. So in this lecture, what we are trying to do is we are trying to build a pipelining the models. Means we are combining all the machine learning models and deep learning models, whatever used here, like face detection, feature extraction, and even the face recognition model and emotion recognition model. So we are combining all the machine learning models and deep learning models and build one pipeline models. So that's what we are going to do in this case. And also we will test the model with the sample data I'm having with me, with a few images like Joe Biden, Trump, Obama, and we also test this image to the Angelina Jolie and Leonardo DiCaprio. For that, let's see what is the emotion and the face recognition that my model is going to be work here. So that's what we are going to see in this lesson. Okay, now we are going to work on new Jupyter notebook. So let me open the new notebook by click on new Python 3. And rename this as 5 pipeline the models. Okay, this is we are working on the pipelining all the models. Let's import the necessary libraries that was really required for pipeline all the models. So one thing is we require the NumPy because it's a dependency library, and we want a computer vision library. We want scikit-learn because we train our model in the scikit-learn, and we also want the pickle is to load our machine learning model. The next step in the pipeline in the model is to load all the models. So we have the 4 models that we are going to use in this pipeline the models. One is face detection, and the second one is feature extraction, then face recognition model, next is emotion recognition model. Okay, now let's load all the models one by one. First is face detection model. So let me name it as face detector underscore model equal to, since it is a deep neural network and we load using cv2.dnn read net from the cafe model. Since it's a cafe model, so we are going to read net from the cafe model. And what we need to provide is the prototext, and we know that where exactly it is. It's a models folder and deploy.producttext. And similarly, also provide my cafe model, which is in the models folder, and the name of the model is ResNet 300 by 300 SST. Let's select this. Next is feature extraction model. So face feature underscore feature underscore model equal to cv2.dnn, and this is a torch model. So let me load the torch model. So read net from torch, and just provide the name of the model, which is the models, and it is the open face and then small version 2. Okay, that's it. This is my feature extraction model. Next one is we need to load the face recognition model, that is detecting the identity of the person. That is my face recognition underscore model equal to, remember this is what my pickle file, and I load using the pickle file. So pickle dot load. I need to provide the file here. The name of the file is the models folder. Let me open that. So open, and the name of the file is models. Now is machine learning face person identity dot pickle. So this is what my file I just want to select, and the type of mode is read in bytes. And finally, we'll also load emotion recognition model. So emotion recognition model equal to pickle dot load, and it was my open, and the name of the model is in the models folder, and the name of the model here is machine learning face emotion dot pickle, and read in bytes. That's my mode. Okay, so done. So with that, we have successfully loaded all the machine learning and deep learning models which are used in the pipeline model. Now the next step is we are going to build the pipeline model. In pipeline model, we did already all the process like detecting and feature extraction and face recognition, emotion recognition. We need to combine all the models. That's it. That's the part we need to do. So what I will do, I will again write the code again for face detection, feature extraction, because I need to do some minor changes. So that's the reason I will rewrite the code again. If you want, you can even copy the code even from the previous lessons. Alright, so for the sake of simplicity, what I will do, let me take one sample image, and to that sample image we will do all the necessary things. Then we'll create the helper function, that is pipeline the model. Okay, now let me consider the image from the test data. Image equal to cv2.mread, and my image is in the data folder. These are my test images. I'm going to take this test image.jpg. Let me show you what exactly this image is. So cv2.mshow, and this is my image. Now img and cv2.waitKey of 0 and cv2.destroy all windows. Execute it. Okay, so this is the image of Angelina Jolie and Leonardo DiCaprio. Let's see whether our recognition model and emotion model can able to detect the face and recognize the emotion. For time being, what I will do, I'll copy this img to image equal to img.copy. Next step, what I'm going to do here is I just want to know the height and width of this image. So h, w equal to img.shape, select first two. Done. The next one, we need to do the face detection here. Face detection. What we are doing here is that we are going to use this face detector model. Before applying this to the face detector model, we need to calculate the image blob. That's going to equal to cv2.dnn and blob from image, and here we need to provide all the settings like image is img and the scale factor is 1 and size is 300 comma 300. Next, mean subtraction value is, we just need to provide the RGB mean, which is my 104 comma 177 comma 123. Next, I need to provide the swap RB to false. Next, also crop equal to false. Done. So with that, we get the image blob. Now we need to set the input for the face detector model. So this is my face detector model, and set the input, and input is going to be equal to image underscore blob. Next, we'll get the detections equal to face detected model dot forward. So with that, what we can get is that we can get the detections here. And remember, we already know that the number of detections you're going to get here is 200 detections. but we make sure that we have some detections. So that's the reason what we're going to do is just specify my length of detection should be greater than 0. So length of detections should be greater than 0. So then only I need to enter into the loop. Now next one is we have the 200 detections are there, and out of 200 detections we will select the detection with the confidence score greater than 0.5. In that case what we need to do is let's run a loop like for I comma for I comma confidence, and basically we are getting the I comma confidence. Will let me take the enumerate, and what you can get is detection. So enumerate will generate the I, and detections we can extract the confidence here. Now in order to get the confidence it is 0 comma 0 comma colon comma 2 will basically get the detections here. So now we got the confidence here. Next step is we need to set the validation, like just select only the phase only if you have the confidence score greater than 0.5. So that's the reason if confidence is greater than 0.5 then only you specify that it is as a phase. Now once we got the confidence, then we take the box. Generally we'll get the bounding box here, and just take the bounding box from the detections, which is 0 comma 0 comma, and this is my ith confidence, and let me take the bounding box from 3 to 7. Next we need to multiply this with the width and height of the image to denormalize it. So let me multiply with np dot array, and just need to multiply with width, height, width and height. So with that I can able to get my bounding box. So next let me extract this. It is the start x, start y, end x, and y. That's going to be equal to, I'm going to consider the box and change the data type to integer values. So with that I can able to get the start x, start y, end x and end y. So we got the data points with me, and what I can do first, let's detect the phase here. So for the phase detection, let me draw the bounding box to this imag. So let me take this cv2 dot rectangle, and now I'm going to take this image, and the name of the image is let me take this image, and the points are start x and start y, and similarly my one more diagonal point here is end x comma end y. Done. So the next part, I just need to provide the color here, and the color is, let me take the green color, it is 0 comma 255 comma 0. So with that I can get my rectangle box. Let me display this. So instead of img, let me display this, and this is what my pipeline model. Okay, let's execute this. Oh, we got some error. It is not in y, it is end y. Okay. Alright, so we can able to detect the face of Angelina Jolie and Leonardo DiCaprio. Perfect. Alright, now the next step, what we're going to do is we need to extract the features from the face. Let me close this. Now what I want to do here is feature extraction. We know how to do the feature extraction, and we are going to use this face feature extraction model to extract the features. Alright, so first one, what you need to do is that we need to crop the face. So that's the reason, let me crop the face. In order to crop the face, let me take face underscore ROI equal to, let me take the image img, now crop it. The index position I want to use here is start x, start y, end x and end y. So let me start with the y. So start y colon end y comma, we are going to take start x colon end x. So with that we can be able to get the face ROI. Now with this face ROI we are going to extract the blob, and that blob we are going to set input to my face feature extraction model. So let me calculate now. Now let me calculate the blob here. Face underscore blob. Let me use exact settings which I use in the data pre-processing. So the settings that I use in data preprocessing is cv2.dnn, and it is a blob from image. And what I need to take here is face RY. Now the scale factor I just used is 1 by 225. Next is the size I just want to use here is 96 by 96. Let me take 96, comma 96. It's not 36, it's 96. And the next one, we will take the mean subtraction RGB to 0, 0 comma 0 comma 0. Then we will set swap RB to true and crop to true. So let me set swap RB to true and crop also let me set to true. That's it. So now we got the place bob. The next step is that we need to set the input to my face feature extraction model. So this is my model. Let me take this model dot, let me take set input, and here the input is the face blob. Okay, so with that we can able to get my set input, and the next step is take the forward and get my features. Now vectors equal to face feature model dot forward. So with that what I can get here is the vectors here. So this is what the features I'm going to get for this face. Now the next step we are going to do here is we will predict with machine learning model. We predict the features with the machine learning model and get the face name and the emotion name. So let me take that. Now face name, we can get the face name, that's going to be equal to, we will take this machine learning model here, that is the machine learning model I want to apply here is face recognition model dot predict. What I want to do here is that I just need to provide my vectors. So that's it. So with that I can able to get the vectors. Let me also calculate the probability, means the score of the face. So let me take that face score equal to face recognition model dot, just need to provide the predict prob A, and with that we can able to get the probabilities of each and every face. And what exactly I want here is that I just want to take the maximum out of this. So that maximum is what the face, the probability of the face name. So with that I can able to get the face score. Let me print these values. So print face underscore name and also print face underscore score. Let's print. Now execute it, and here you go. What you can see here is that we got the Leonardo DiCaprio. The probability what we got is 81%, and Angelina Jolie, and the probability what we got is 58%. Okay, but what is Angelina Jolie and what is Leonardo DiCaprio? Let's see, like, what this machine learning model able to get this. Let's look into that. For that, what exactly we will do is we will put the text here. Okay, let me put the text using cv2 dot put text, and here I just need to provide the image for which I want to put the text, which is image. In order to set the text here, we need to provide this text here, and as you can see this is getting in an array. So let me take only the first value, which is 0. So with that I can able to get the Leonardo DiCaprio here. Now let's take the text here. Let me put this text. The text is going to be equal to, for timing let me put the text. Okay, text underscore face equal to, let me create some string, and here I'm going to insert the text, and also let me also insert the probability score out of this. Okay, for that let me take the format and let me insert the face underscore name comma face underscore score. So now what I can give here is that this face name comes here and this face score comes here, and in order to get the values in percentage, just multiply that into percentage, and this one here let me mention here is percentage here. But in order to get the 2 decimal points, what I will do, let me take colon and dot 2f, we can get the 2 decimal floating points or 1 decimal floating point, or you can put 0 decimal floating point is basically the integer values. Okay, so with that I can get this one. So let me take the text face, and where exactly I just want to display is the origin. Let me take the start x and the start y. That's my origin. It is start x comma start y, or my origin. Next one I just want to take here is the font face. Okay, let me take the font face to basically what kind of font I just want to give here. Let me take cb2 dot font, and I'll take plain. Next one in the put text is font scale. Let me take 2. Next is color. Here I'm going to use some white color, 255 255 255. With that I can get the white color. Next is thickness is 2 pixels. So that's done. So with that we can able to put the text on top of the image. Let me execute this. Okay, now we can see that it's a perfect. That's Angelina Jolie. This is Angelina Jolie with probability score of 59% and Leonardo DiCaprio with a probability score of 82%. That's really good, right? It's a good model, but I just want to mention you that whatever the model we build, it's still not perfect, but we can improve the model with some other techniques like deep learning. Anyways, similarly, let me also display emotion. So emotion, and that's going to be equal to, in order to get the emotions, I'm going to use this emotion recognition model. So let me take this emotion recognition model here, and similar, just like we applied to the predict the machine learning, just like that we'll take the emotion recognition model here to get the emotion, take the predict and pass the vectors of 0 to get the emotion. And next what we can do here is we can get the emotion. That's it. So with that we can be able to get the emotion here. So more precisely, let me give emotion name, and in order to get the score of this or probability score of this, let me take emotion score equal to emotion recognition model dot predict prob a. I need to provide the vectors here and take the maximum out of this, which can able to get the emotion score. So let me also print this emotion and name, and also print emotion score. And okay, and here you can see that we got for Leonardo DiCaprio we got the emotion is neutral. Okay, that's really cool. And the probability we got is 22%, and for Angelina Jolie the emotion what we got is happy. That's correct. Okay, let me display on top of the face here. You can display on top of the face. Let me use the same, exactly the same thing, text face, and let me also take the this one is text emotion. Now here I just want to replace face name with emotion name and face score with emotion score. With that I can get this. And also let me take this put text here, and the text, instead of this text place, instead of this text face, replace that with text emotion. And start x and start y, instead of that what I will do, start x I will use the ny. Next, cv2 dot font face is this plain, and I'll do exactly the same thing, all the same settings. Now let me execute this. Here you go, we got that for Angelina Jolie it is the 59% probability and the emotion is happy, and similarly for Leonardo DiCaprio this emotion is 82% and it is a neutral, and the probability given is 22%. That's fine, that's really good. This is really awesome, right? We build a model from nowhere to really something. I'll see you in the next lecture more on this. Until then, happy learning. Hey everyone, welcome back. So what are you going to do in this lesson? We will create some helper function, and we will use that function as a pipeline model function. So that I will use this function for the further use. So let me make that helper function here. First and foremost, let me copy all these things. The first thing is that we really don't require this. So let me remove this and paste it here. and remove the unwanted prints. We really don't want this now. And the next step, what we're going to do here is, let me select all. Now make a tab and we can get the indentation here. Now what you can do here is just let me create the function and name the function as pipeline underscore model. So that's what the function I'm going to use now. And the input for that is image path. So this image path I'm going to pass into my image read. So that's what I'm going to do here. And with that I can get the image read and get all the values. Now I'm going to return image. And that image consists of the face detection, face recognition, and also the emotion. So that's it. So that's what we're going to do here. So this is what my helper function. Oh, syntax error. Put the colon here. All right. So let me use this pipeline model, and let's see here. And the output here is img1 is going to be equal to pipeline. And I'm going to pass the path here. The path is, let me use the different images now. First one image I'm going to use here is, okay, let me test this, a test image which I used the previous lessons. Okay, this is my image. Okay, now execute this. All right, we got this Angelina Jolie and Leonardo DiCaprio, and this is what the emotions we got. Let me test with some other models. So let me take another model like Joe Biden, Trump, and Obama. Let me take this. Okay, let's look into that. This is a Joe Biden. It's okay. It is 60%, and the emotion is happy. That's correct. And this is a Donald Trump. Correct. Barack Obama is correct, and his face seems to be neutral. That's okay. Correct. Donald Trump looks angry here, but even the neutral is also fine for me. But anyway, the results what we got, I'm okay with these results. Let me also test with some other models. I'm going to explain you that, like, what are the model we have, it's still not 100% perfect model. We can still improve our model by adding more and more data and creating some different algorithms like deep neural networks, convolution neural networks. That will definitely improve the results. Let me also show you one more image, and this is Salman Khan and Amir Khan. Let me display that. Okay, that's correct. Amir Khan is correct. It's 49%, and Salman Khan is correct, 71%. And Salman Khan seems to be neutral. It is 24%, but this is wrong, right? Amir Khan looks happy, but it is going to display the sad, that is 29%. It's okay. Like, we know that our model has 30% of cross validation score. But still it's giving the most of the results are correct. Like, there is a possibility that you might end up with wrong results, so that can be improved with the data quality, and also we need to train with some other deep learning models. Okay, let me also display some other image like the Scarlett and Robert. Okay, let's look into this. Okay, this is Scarlett Jason is correct. She looked happy. And whereas Robert Downey Jr., it's displayed as Salman Khan. That's wrong. This is the Robert Downey Jr. That's wrong, but it's okay. But this is the emotion is correct. Like, he's more neutral. Okay, what I'm going to show here is that we got few good results for few bad results, but most of the cases we got the good results. In order to get more and more accuracy, we need to train with deep neural networks or some convolutional neural networks. That will definitely improve the accuracy. But training the data with the convolutional neural networks and deep neural networks is beyond the scope of this course. Probably you can try by your own, because you know the procedure and you know how to train all these things. And only what you do is that pass to the deep neural networks, and that will increase the accuracy of the model. And make sure, like, don't overfit the model. And if you overfit the model, you will get even wrong results. My suggestion is underfitting model is better compared to the overfit model. Overfit model is highly unstable, so you can't predict it. In underfit model, at least you have a very good precision. That's what about the face recognition. In the next phase, we are making this project to the next level, that is building the web application of this using Django. I'll see you on that. Until then, happy learning.